Hello, my name is Dakota Weir. This is Reagan. This is Lucas. And this is Kellen.
So this is us. Yeah. And first, we would like to say the science behind the experiment. And the science behind the experiment includes that, of course, strawberries need to germinate, which is the development from a plant of a seed or spore after a period of dormancy. From eating a strawberry, there's many benefits. Some benefits are boosting immune systems, aiding digestion, managing blood sugar, and reducing the risk of some cancers. And some more benefits from strawberries in general are that they make people happy and give vitamins that also help others. And you may be wondering how strawberries make people happy. Well, they taste good. And its association with nice memories also make people happy.
Why we picked strawberries and what inspired us. This project was both exciting and complex, requiring extensive research and thoughtful collaboration from each member of our team. Our inspiration began rather spontaneously. That don't make no. And it immediately resonated with everyone. While watermelon was our original idea, we quickly realized that its size made it impractical for the parameters of our design to. Oh. So we moved to something smaller and more manageable. Why we picked strawberries? Because strawberries are small, so they won't take up as much space as our first choice for the project. Number two, they have very few requirements to start germination. Number three, we were the only team to do strawberries out of our whole school, so we were the only team that chose this project. Number four, the project was very interesting to do. Number five, we all learned a lot from it. And number six, they are easy to germinate.
As Reagan said earlier, we thought about using watermelon instead of strawberries at first, but watermelons are bigger when fully grown and would be too big to have on the ISS, and strawberries are smaller and germinate quicker. Strawberries also have a better nutritional value than watermelons. Watermelons have 46 calories, 0.9 grams of protein, 11.5 grams of carbohydrates, and 0.2 grams of fat. But strawberries have 46 calories, 3 grams of fiber, and 1 gram of protein, making strawberries a healthier food to have in space.
So my part was to find what the astronauts are supposed to do, step by step, the conclusion, and all the things of that. In order to conduct this experiment, the astronauts will need to use tube volume 3, which will contain 12 seeds, 2.75 milliliters of spring water, and 2 drops of fertilizer. When the astronauts perform our experiment, these are the steps that they will need to follow. First, open clip A, then shake gently for 30 seconds. After that, they will need to expose to light for 90 seconds. Next, Next, shake gently for 30 seconds and add light for 120 seconds. Then for other days, expose the tube to ambient light. Finally, open clip B and shake gently for 30 seconds. In conclusion, we expect for the strawberries to grow in microgravity like they do on Earth but will have a different process in order to grow. So we would like to thank you for everyone who is in this establishment, and especially to Miss Teresa, sorry, her right there. She helped us out a lot. It was really just, she was really helpful to all of us. Here, I'd like to thank all these parents for just being there for us, and for our assistant principal to be here. Thank you for supporting us at the last minute. Our principal had to, yeah. So, yeah, just thank you to everybody, even the ones who are just seeing this right now. Any questions?
Any questions for our team?
Okay, so I would like to say for the record that you're all sixth graders, right? You are the youngest team presenting here. You did a fantastic job. From the science vantage point, you were looking at nutritional content of strawberries versus, say, watermelons. You were looking at the engineering constraints imposed by the mini laboratory to be used, so you wanted something small. You were looking at whether or not germination was straightforward. Those are all the kinds of questions that researchers have to ask when they're doing an experiment constrained by engineering and technology. And I think the other thing to point out here is that we have heard very sophisticated presentations from undergraduate institutions. We are seeing middle school students, high school students. They're all using the same mini laboratory. It's a capability that's very straightforward. You're able to combine in a prescribed way 3 small volumes, so essentially 3 small test tubes of fluids and solids. And the sophistication of the experiment critically depends on the sophistication of the fluids and solids that you're choosing. So it's wonderful to see 6th graders and undergraduates in the same group presenting on experiments using this same flight hardware with the SSEP initiative. So again, you did a fantastic job. But I'm going to give it back to you because there may be questions.
Could be questions. Any questions? Did someone have any question? Okay. You got a question? Too bad. Okay, well, thank you guys very much. Great job.